Lila, here's a piece of what looks like ordinary tissue paper, right?
Mm-hmm.
I'm going to hold it over the candle flame. Watch what happens.
Hey, where'd it go? How come there's no ashes or anything?
Well, this kind of tissue paper has been treated with nitric acid and sulfuric acid to dissolve away all the material that would normally be left as an ash form. So there's no ashes. So it changes completely into a gas. Here, you try it. Use the tongs, though.
Okay.
Okay. Gone.
Glad I wasn't holding that.
Right. Now, that time you touched it right to the flame. But as the result of the treatment of the paper, it burns at such a low temperature that you can hold it way above the candle flame. Try it again. Here, take the tong and hold it way high above the candle. Oh, that's not very hot up there either, is it?
No.
Yeah.
I can
Try that
hardly
again.
feel it.
Start higher.
Okay.
Okay, now slowly bring it down. This is one you ought not to try at home unless your parents are around because you're using fire. There you go. Pow.
So
Now
like an explosion.
This is called flash paper, and you can buy it at a magic shop. And magicians use it for making all kinds of tricks. But another thing that it illustrates is what happens with a shooting star. Have you ever seen a shooting star, a falling star?
Yeah.
Okay, well, this is a little piece of interstellar dust that's being drawn towards the Earth by the Earth's gravity. And the candle flame there represents the edge of the Earth's atmosphere. So watch what happens as this dust comes along here and finally hits the Earth's atmosphere. You have a shooting star.
Neat.
Isn't that neat? Here's another one.
How come the real stuff catches on fire?
Well, because of the friction of the air.
Oh.
And this, of course, we're using a candle flame. Here goes another one. Now, I thought, now that you understand the general principles behind the whole thing, here is a nice big sheet of it, which we should make a nice big flame. So hold it in the tongs and bring it...
Do you want me to hold it high?
Yeah, and bring it over the candle flame way high, and look out, here we go. There you go, gone. I assume you've used a broom before, Kristen.
Yeah.
Why do they always make it out of this sort of springy stuff like that?
Well, maybe because it's more flexible and it can pick up the dust easier.
Yeah, it can pick up the dirt easier. Well, the fact that it's flexible down here means it's also flexible up at this end, but you never use that. And you and I are going to use that to do a kind of an exciting trick. See that orange sitting over here?
Yeah.
Well, this orange just fits inside this cup. But between the orange and the cup, I'm going to put the styrofoam block, like that. And the object is get orange into cup by yanking the styrofoam out of the way. Here, let me try it first.
Uh-oh.
You know the principle involved in this?
Yeah.
You've heard about inertia?
Yeah.
What's that?
That's when you keep something in rest when it is in rest.
Yeah, if something is at rest, it will tend to stay at rest.
Yeah.
And if it's moving, it'll tend to stay moving. Well, in this case, if we can move that piece of plastic fast enough, the inertia of the orange will make it stay right where it is, and gravity should pull it down right into the cup. So what you do is you get the broom, and you push on the broom to get all the springiness right like that, and then you pull it back and let it go so that it hits the plastic, not hit the cup. And if you do it fast and hard enough, orange drops right into cup. You want to get the plastic? You can try it. Okay. Now, and get your foot on the broom. This time we're going to use the springiness of the broom handle. Okay, go! Oh, you didn't let it go quite fast enough. So try it once more. Pull it way back and then let go very quickly. Okay, way back and let it go quickly. There you go. Congratulations, you did it. You know where to locate the Panama Canal. It's the man-made waterway that connects the Atlantic Ocean with the Pacific across the Isthmus of Panama. As a ship leaves the Atlantic to go the 51 miles to the Pacific, Is it going east or west? From the southern edge of Mexico to the beginning of the continent of South America, the land in general runs from the northwest to the southeast. But in Panama, it takes a northern bend, so that a ship going through the canal is heading in a southeastern direction. When it starts its journey at the entrance on the Atlantic side of the canal, it's actually to the west of where it will be when it leaves the exit on the Pacific side. So a ship going through the Panama Canal from the Atlantic to the Pacific is going from west to east. Scott, you like surprises?
Yes.
Okay, I have a very interesting surprise for you. But first, you've done some work with a computer, I understand.
Yes, I have one at home.
You know, how about a robot?
No, but my dad has one at work. It's this big.
You know, and what can you do with it?
You can move it around with a little remote control.
So you're familiar with remote controls like this.
Yes.
This one, you push this to make it go right and left, and there's a switch in the back here to make it go. Well, this is a remote control for a friend of mine. Does your robot talk?
No.
Well, I'd like you to meet one that can.
Oh, neat.
Notice? The remote control is not plugged in, however. This is a robot that was designed by a friend of mine, Jim Lytle, along with a lot of other people, and it has been programmed to come in here, turn, point its little head at you, and say something.
Hello, my name is Hero. Who are you?
My name is Scott.
You understood him all right? My name is Hero.
Yes.
Well, that Hero is a sort of acronym for the kind of computer that this is, in which we can take it all apart and look inside and find out how it works. Here's a plug.
Okay.
We'll plug it in around there at the back. Take the remote control.
There.
Okay. Now push first reset.
Ready?
Thank you. Now you know how to work the remote control. Push the switch on the bottom, and here's your right and left turn right there.
Okay.
Let's go into my workshop. We'll take off a side panel so we can sort of see what makes them talk. Turn it around here. Okay. Now I want to turn this around here because I want you to get at the switch, the control panel, which is right there.
Okay.
Now see this little tiny thing right here?
Yes.
That little unit right there is the thing that makes them talk. And out here comes his speech. Now, Jim gave me some programs for you to run. You know how to work a computer?
Yes.
Okay, push ready.
Ready.
Ready?
AD
A, D,
24
24,
E0
E0,
3.
3. Sounds like garbage to me.
And it actually was not garbage. You know what it was? Those are all the sounds that Hero can make. They're all the various combinations of consonants and vowels and whatnot. And with those, there were 64 sounds that you just heard there. It can make up any word in any language. See this little dial right there, that little circle?
Yes.
You turn it slowly.
Ready? 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 Ready?
What's happening?
It's getting louder or it gets slower when you turn it this way and faster when you get
Well,
that
not
way.
only slower and faster, go all the way this way.
Different
now go all the way
tone.
up the other way.
Ready? Ready?
So it's faster, but do you hear something else?
Yes.
What?
Different tone.
Different tone, yes. It's a higher frequency on this end and a very low frequency on the other end. So you can set it at
Ready?
to make them speak
Ready.
in kind of
Ready.
any kind of inflection that you want. Scott, you said your computer didn't talk, right?
Yes, that's right.
Yeah, okay, well, that's why I wanted you to sort of play with this one. And here, take a look at the book. That's some of the words in its vocabulary.
It says a whole bunch of words in here.
Right?
Friend, glass, government, harmony, heart, no. And I bet you I know what those numbers mean.
What?
It's just like a program in a computer.
Mm-hmm. That's exactly what it is. It's a program in the computer that makes this Hero talk. Now turn the page over. Jim programmed a special one for you. Go ahead, punch it in.
Okay. Reset.
Ready.
A, D, 0, 2, 0, 0.
Now
I
listen.
am incapable of making a mistake. Therefore, you must be wrong.
What'd you say?
He said he's incapable of making a mistake, therefore I must be wrong.
Do you agree with him?
Yes.
I can't do it.
You can't blow up a baby's nursing nipple?
No, I don't think anybody can.
No, it's very strong, isn't it?
Yeah.
Very, very hard to blow up. Well, before you leave today, we're going to blow it up.
Okay.
Let's put that aside for a minute because here's another question. Here's a can of soda, and here's the nursing bottle that goes with the nipple, right?
Yeah.
You know there's gas dissolved in here.
Mm-hmm.
How do you know?
Well, if you shake the can up, then the bubbles will get all active and everything. And if you open it, it'll squirt out really
Squirt out,
fast,
right,
and then or the bubbles will go in your nose
Right.
and
You can
on
feel them in your
face.
nose sometime when you drink.
Yeah.
That's why one of the reasons you buy this is because of those bubbles in there, carbon dioxide gas. Okay, my question is how much gas is actually dissolved in this liquid? Because is there from here up to there, from there up to there, or there up to there? We're going to pour that in here eventually. How much?
see.
I know it's a guess, but go ahead.
Yeah.
Just take a guess.
maybe from there to there.
Okay. So you open the soda. I'll
Okay.
get the nipple ready to put it on the top. You pour the soda into the baby bottle. Try not to lose any gas. We're already losing some, right?
That's
As
right.
you're pouring, it's coming out.
Yeah.
Okay. Now remember, I told you before that this is the type of nipple that does not have a hole in it.
Yeah.
Mother is supposed to make her own hole, so nothing can escape. Would you gently turn the bottle upside down and back?
Okay.
Thought you couldn't blow up the nipple
I couldn't. I don't know how this is happening.
because there's so much pressure from the gas.
Oh.
You know why it's coming out, by the way? When you agitate it, the
No.
liquid is dissolved in the gas is dissolved in the liquid, and if you shake it, you make it come out of solution. Also, if you add sugar, that's how sundaes and sodas work. Okay, once more, and you should be able to get all of the liquid into the nipple. There you go. You see joggers just about everywhere you go these days. Running is supposed to be good for you. If jogging is good for people, is it also good for cows? Well, cows jogged along at 2 to 4 miles per hour around a special track developed by dairy scientists at Utah State University and the U.S. Agricultural Service. Years ago, dairy cows moved around in pastures, but today they're kept in pens and fed a prepared diet. As a result, they're out of shape. Before putting a cow on a jogging program, scientists check its heart with an electrocardiogram. Doctors recommend a similar checkup for people before they start jogging. They record data on the cows before and after exercise to find out if there's any correlation between running speed, distance, and milk production. After just 4 weeks of jogging, cows produced more milk on the same amount of feed and gave birth easier too. Now, you won't see cows jogging along country roads, but the study suggests that farmers allow their dairy herds to be more active because jogging is good for people and for cows. Can you think of any place where reaction time is important? How long it takes you to do something?
In driving, when you see a car coming, you should press the brake.
Mm-hmm. Or even steer, so your hand reaction time is also very important. Well, there are various methods of timing reaction time, but here's one of the simplest that you could do at home very easily. Get a piece of paper and put in 12 squares, and then put numbers from 1 to 12 in the squares, but not in order. See, there's 1, and 2 is over here, and 3 is way up here. So what you have to do is touch each one of these squares in order, first 1, then 2, then 3, and count out loud and get up to 12. Meanwhile, I'll start the stopwatch. Just do it once to practice. You ready? Go.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Okay, that was about 9 seconds. Okay, now this time you're going to do it. Now that you've had a chance to do it, this time you do it as fast as you can.
Okay.
Touch each one. Make sure you touch each square and count them out loud. You ready?
Okay.
Go.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Okay, that was 7 seconds. 3 seconds better. One more time. Now, this is fast as you can possibly go. Ready? Go.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Ha-ha! 4 seconds. So when you make this up, well, you can try this on all your friends. Have a contest to see who can do it the fastest. And I think practice helps in this case, doesn't it? Because you kind of know where they are. Now, that tests that specific job, this particular challenge. Here's another way of doing it that you can do at home also. All you have to do is look up what the distances are. Here's a ruler that I'm going to drop. Give me your left hand like this, and hold your fingers right opposite that red mark like that. Then I'm going to drop the ruler, and as soon as you see it move, you close your fingers to catch it. Ready?
Oops.
Oh, read opposite here, you see? 0.24.
4.
Okay.
Oops.
Try it again, now that you get the idea. Okay, that time,
0.2.
2.
Oh.
0.20. That's a fifth of a second. One more time and see if you can increase your... There, hey.
0.18.
That means that it took that long for gravity to pull down on the ruler. But it also timed something else, didn't it? In other words, what happened when your eyes, you saw this start to move, that sent a message where?
To my brain.
And then what?
And my brain sent the message to my fingers.
Right. Now notice, here is a longer ruler, and if the first mark on it, you'll notice is about opposite the 0.2, right? That's where you grabbed it. So that was about your average speed right there, 0.2. Okay, but this time the longer ruler is to check how fast you can react with your foot. Do you think your foot will be faster or slower than your fingers?
Slower.
Mm-hmm. Okay, this time, you step back. I'll put the ruler down here like this.
What do I do?
Just put your foot out here
okay.
like this. And here is 0.2. Here's a little clay ball, which I'm going to drop and try to hit you on the foot. You move your foot the minute you see me let go. See? That's 0.2. Got you easily, right? Here now, here's 3. 0.3. Ah, you missed you. Once more.
Whoops.
Ah, didn't get you that time. So your foot was a whole tenth of a second slower than your fingers, right? Yeah. So this is a good way to test reaction time of your friends and your family by finding out from a book what these various distances will be, and then check their reaction time with a ruler like this or with a ruler like this to see whether their foot is faster than their hand. Using curved mirrors to concentrate the sun's energy is the idea behind 222 mirrors out on the desert. Well, have you ever heard of the trick where you yank the tablecloth out from under the dishes?
Yeah?
You ever done it?
No.
Today is the day. You're going to do it.
I can't do it.
No, you're going to yank the tablecloth like this right out from under all the dishes. Well, wait, first let's practice. Practice. Here this piece of paper represents the tablecloth, and here's this glass of water, which represents the food. if you pull slowly, there's enough friction between the glass and the paper to make the glass move. But when you get right to the edge like this, here's the serial secret. Quick! Jerk like that. You try it now. The faster the better. Go ahead. Pull it slowly so that the friction overcomes the inertia. And now when you get close to the edge, a little more, a little more, a little more, right there. Now quick, jerk the paper. Ah, that's the idea. Now you know why that works?
No.
Well, because there's a inertia, which means the tendency of an object when it's still to stay still, or if it's moving to stay moving. And what you do is you quickly jerk like this, the inertia of the glass will keep it right there. Now you're going to do it with the tablecloth and all the dishes. If you don't mind, I will move the glass of water over to the side, okay?
Okay.
Would you like me to show you how to do it first?
Yeah, I think so.
You don't seem to have a great deal of confidence.
No.
All right, what you do is get the tablecloth like this and get ready and do it just like you did with the paper. But move and move fast as you can. Are you ready? Notice, by the way, the knives and forks came off because they don't have much mass, so they don't have as much inertia. But the rest of the stuff stayed on.
Yeah.
Okay, you want to pick up the dishes? We'll put the tablecloth on, ready for you. And notice this is not a real tablecloth. It's a very sort of thin piece of material that's kind of nice and slippery, and I got it real long so that you'd have a lot to pull. Okay. One sandwich, 1 cup saucer, knife, fork, and spoon. Nothing in the cup, by the way, just plastic dishes also,
Yeah.
just in case. Now, you got the idea?
Yeah.
Just like with the paper.
Okay.
Once you start going, don't stop. Go as fast as you can. Are you ready?
Yeah.
Anytime. Ha-ha! There, you did it.